Okay. Now this is possible because of the efficiency of the 3D rendering machine or engine. In the old days, how would you do interactive design? You just draw a lot of sketches, right? And if you want to change, you draw another picture, right? So with interactive parametric design, is only feasible if you work with digital media, and that's where come in. Now, I want every one of you to start Mathematica program. Just start it. Okay. Now, I happen to have my own version. So, okay. Have you guys started? Okay. I want you to key in something like, okay. Let's put key just like I said, graphic. Okay. Graphic 3D. So this is graphic 3Ds, right? And let's see. Graphics 3D and Cuboy. Okay. I don't know. Okay. Oops. Let me make it a little bit bigger. Can you guys see? Okay. 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 Let's see if this come up with anything. Right. Okay. Type this. Now, I'm not. So Mathematica is both a language that's called Wolfram as well as a software. So it has built-in application. So it might take you a while, but just type exactly what I did, right? Graphics 3D, open square bracket. Anybody have trouble so far? Because I'm just gonna go. But that's a picture come up. Okay. Here's a hint, guys. If you type something and the program doesn't know, it's in blue. Okay. So if your name is Jim and you type in Jim, it's in blue because it doesn't know Jim. Okay. But the built-in function, it knows, so it's in black. So if you type something and it's in black, you type correctly. Okay. If you don't get the right result, chances are you don't. Okay. So just type this. Okay. First of all, what's a cuboid? Okay. What's a cuboid? Cuboid is a cube. Okay. A cube is a what? It's a box. Okay. The reason it's a cuboid, not a cube, is because it doesn't have to be square. Okay. Right. So now, graphics 3D, just say, show me the picture. That's all it does. Okay. So this is again, I don't want to spend so much time because I'll come back to the introduction of how things work. But basically, Mathematica, things like Python, these are called functional programming based, meaning that when you ask a computer to do something, you request in terms of a function, right? So if you want your mom to make a breakfast for you, right? You say, Mom, can you make coffee for me, please? Now, in Mathematica, it would mean something like your mom has a function called make breakfast, and you just type in make breakfast. Okay. And if there's a choice, for example, you can say make breakfast, open bracket 1, means you want 1 egg. Make breakfast, open bracket 2, close bracket. That means you want your mom to make 2 eggs. Okay. So your communication with the computer is through a function. Okay. A function has a name. So the built-in function has a name. Now, in real life, you would start to program your own function, but right now, just using the built-in function, okay? So that would be like your mom has a built-in function of making omelet, right? But you don't like omelet, you like egg Benedict. So you have to create another function and then give it to your mom. Say, okay, this is how you make egg Benedict, okay? So now we're gonna use a working built-in function. Function is called cuboid. Cuboid create an object that looks like a cube. And graphic 3D just say, show me. Show me, okay? Oh, okay. Can you help somebody? Ah, okay. So it does come in black. How about cuboid? Is that in black? Square bracket, guys. Okay. Anybody has trouble with YouTube? Yeah, square bracket, guys, not curly bracket. Pay attention. Yeah. Okay. Okay. So you might have some problem. I think okay, raise your hand, those of you who got this picture or something similar. Okay, good. Fine. Okay, come. So I think by the way, this is where you can actually talk to each other, help each other. I don't mind. Okay. This is the part where you can start chatting. Okay. Help each other. Okay. Now I'm gonna talk over you guys. So okay, and stop talking for a minute. Now, is this if this were something I designed, what am I doing? I'm just helping you visualize, right? So this is a preview. So this is not interactive and it's not a design project. Now, what if I want to make this a design and I'm choosing the color, okay? So I can choose different colors. Well, let's better than choosing a color. Okay, go to here, click on the middle of the word, cuboid, press F1. That is a universal help. For some reason, it's not helping. Okay, now you would see that right now, okay, it's not parametric. What do you mean by it's not parametric? It doesn't, it only allows you to say cuboid, right? So now next step. Okay, next step. Oh, I shouldn't put it here. Next step. Okay. What if I specify 3 coordinate? Okay, 3 coordinate. Okay, now look at me, guys. Now pay attention. I'm going to put in coordinate. Now, when I put coordinate, I use curly. Okay, so let's do curly. Curly 0, 0. Oops. Okay, close curly, comma 1, 1, 1. Okay. Have you typed it in? Okay. So what this does is it draws a cuboid that is located from 0, 0, 0 to 1, 1, 1. Now, does it look any different? No, it doesn't. The reason it doesn't is because 0, 0, 0, 1, 1, 1 is such a basic parameter. It's used as a default. Now, what if I do this? Let's make it 1, 2, 3. See? So now it is the x-axis. This is 1. This is 2. This is 3. Okay. Let me say that again. This thing say, show me the picture. This thing say, make me a cuboid. This one say, starting from 0, 0, 0, and x is 1y, y is 2 deep, and z or z is 3 high. Okay. Okay. Now, okay, are you happy with this? Okay, let's say you are happy. Okay, let's say you're happy. Okay, let's say you're happy. How can I make this interactive? Exactly. So let's do one thing at a time. Okay, let's do one thing at a time. Let's say I just want to manipulate the height. Okay. So instead of having 3, I put in h. Okay. Have I lost anyone so far? Right. And once again, I put this inside a function that say manipulate. You know what manipulate is, right? Play. Okay. Play with h, comma, h from, let's say 1 to 5. Okay. Now watch this. Now this is not that pretty, right? It's a silly little design. But that has all the element of interactive parametric design. Interactive, this is not your client. Well, actually, you know what? You can do this. Instead of showing the client just one picture, you can actually ask your client to play with this. This is called like customization. Okay. Earlier, I was making a hard distinction and say, you fix the design, you show your client. But while you're making the design, you have the parameter you can play with until you're happy. Well, there's another way of doing this, which is to say, show the client exactly this and have your client play until he's happy. Okay. So this would mean something like, I'm going to design a box for you, but I don't know if you like tall box or short box. So I give you this and your client goes, this looks pretty. And then you make that. Now, this, by the way, okay, once you got this, you can export from Mathematica into a 3D printer file format. Send it to the 3D printer and it will print. Okay? I've done that. I've done that. Okay? Not this one. This one is a stupid looking design. I'll show you what design I did though. I use this design. Okay. Now, let me ask you, okay, just look at this for a minute. How would this be parametric design? Let's say I'm happy, right? I'm happy with this. This is kind of like a little game I'm just making up. Let's say I'm designing SCII logo, okay? This is my proposal to the client, okay? You can imagine the client can say, well, you know, I like this, but I don't like blue. I like red. Can I make it red? Or I like this to be a little bit taller. Now, in the old days, right, I would have to go back and make another design and draw this picture. Now, instead, what do I do? What do I do? I give, let me show you an example. Hold on. Let me start the app. Obviously, it takes a lot more line than just a simple one. But here's what it looks like. Okay. Okay. Let's say I show this design to my client. Say my client, you own Basai. Say you don't like this color. Okay. You don't like yellow. Let's make it red. Okay. You want it to a little bit taller, move up and down, right? You can make it thinner, thick, thin. You can make this tall or short, or you can, I don't know, lengthen this. You can move the angle. You can move the angle and you let's move it separate out a little bit, right? So this is what I mean by interactive parametric design. It's not just you anymore, right? You can literally sell your client the whole package like this. And your client say, okay, well, you know, I'm going to make it fat. Oh, that's a little bit, right? And then you can visualize in 3D. Okay. So obviously that's one SCII. That sounds a little bit fat. Okay. You can make you can make the thing, you can make it, you can make it conical. You can do all kind of stuff, right? Now, finally, just for fun, you can do animation, right? Now, I'll show you what animation looks like. And actually, I did this already. So all you need to do is, right? So now this is animation, okay? Now I can animate between 3D and 2D. I can animate this design 2D and 2D. I can animate from one design to the next in 3D. I can do it in 2D. Right? Now, this would mean that I'm very capable of giving. You guys are very aware of the pitching concept, right? You're doing all this prototype and pitching. But what you're not yet taught, and you will be hopefully, is that client participation means a lot. So when you pitch something that is static, even if I do the motion, let's say I pitch something like this, right? I pitch something like this. Is this a static design? Yes, it is a static design because the client can only like it or not like it. If the client doesn't like it, you go back to the drawing board. But if you give them something like this thing, and you can literally deploy this in cloud. So I can deploy this in cloud and the client can play with it and then tell me what the final configuration is. So this would be maybe a little bit purple, a bit shorter and so forth. Send it to me. I save the config as a 3D printing file, send it to 3D printer, print it. Okay. This is what I mean by interactive parametric design. Okay. Now, I want to, because this is a little bit of, it takes a little bit of getting used to. You are going to require some kind of workshop, and we do have like a workshop time, right? So what I want you to do is, okay, and this is for your turn-in homework, right? So you turned in this in at the end of the class. So let's go back to our simpler one. Let's go back to our simpler, this one. Okay. Okay. I want you to, okay, well, you have this, right? Okay. Now, I want you to save this as, save as, okay? And then write in your student ID. Okay. So for example, my student ID is 65412, whatever. Okay, save as that. That's the one you're going to turn in. Now, obviously, everybody's going to have exactly the same thing, right? Well, I don't want you to do the same thing. I don't want you to do the same thing. I want you then to do this. Okay. Can you go to here and then press F1? For some reason, my F1 goes to, oh, because I'm using Zoom. Okay. Yeah, I'm using Zoom, so my F1 is the volume. But if you go to this and you type in F1, let me stop share for a minute. Let me go to there. Okay. Basically, okay, there's a web. You go to the website, it should come up. If you press F1, it should come up. Raise your hand if you press enter F1, it doesn't come up. Okay, then you can do this. You can go to website, reference, okay, reference. Let me go to the line group. Okay. Reference.wolfram/language. Dimutu, can you send this? Okay, well. Give me a minute. Yeah, can you send? Yeah, can you send this? Just type in first. Reference.wolfram.com/language reference QBoy. Search. This is Mathematica reference QBoy. Okay, so you can see that this is exactly sort of like a user page. So I can draw this, right? Okay. Now, go to this example. Okay, go to this example. Right. Okay. Copy this, and go to your clipboard and just paste. Right. So this is what's cool about this Mathematica use. You can just copy it. Now, or you can copy it in this one. Right. So the difference between here is that I put in yellow and the shape. Now, because I don't put in the end, the beginning is 0. I don't put in the end, it's assuming the size is 111. So this is one of those things where if I put something else, like, oops. Yeah, reference Mathematica, yeah. So if I go something like 1, 2, 3, like before, I'm going to get this, right? Okay, so if I don't put it, it's the same thing as 1, 1, 1. So you notice that this thing say that you can write nothing and then put it inside. So let's go to this. Okay, so what's the difference between what we did before and here? Here, instead of graphic 2D, one cuboid, I put in the bracket 2 cuboid, and one's blue, one's yellow. Now, what if I want to move this thing in and out? I can do this, right? I can turn this into D. Okay, I can turn this into D, and I can do something like D from 1 to 7, say, and then I can manipulate. Okay, so now I can move far apart or move it close to each other, right? I can move this thing in and out of each other. Cost nothing. It costs me nothing. Now, let me show you what animation looks like, by the way. Animation, all you do is click down here and play. Okay. But that's just for fun. I don't know. Yeah. But you can move this by hand. Okay. Right. Now, at the end of the class, I want you to just use cuboid, right? Just use cuboid, 2 of them, and change something. Okay, change something. You can change the distance. You can change the size. I don't really care. Okay. Now, you can change 2 things. So if I want to make this distance horizontal and make another one, D and P, D and G, okay? I can do this. Okay, now I can change the distance here independently of this distance. Right? So in other words, I want you to go. Okay, now my line is up, can send you directly. I think the Mutu probably sent you already. Yeah, okay. Okay. Have you sent it? Yep, that's it. Okay, so the Mutu already send you the. Oh, okay. This one, okay. This one, after the backslash, type in cuboid. Okay, let me, I'll do it for you. Give me a minute, let me send to you. Okay, what Dimitri send you is the whole reference page, so it covers everything. I'm just gonna send you the page on cuboid. Language/reference. Okay. Okay, there you guys. Okay, I just send you the particular page. Okay, so click the link that I just sent you. It should take you to this page. Okay, once you go to this page, click here as your starting point, copy into your thing, and now you can play with whatever you have. You can move this, you can move that, you can move the beginning, you can change the color if you like. Okay, let me change the color for you. Okay, C and color. Now, because color is a discrete set, I have to do something like this. Red, blue, green. Okay. Okay, guys. Okay, quiet for a minute. Just look at me, look at me. Okay, guys. Manipulate tells me to do interactive. Interactive on what? In this case, my example is there are three things I'm going to make interactive on: D, G, and C. Okay, D, G, and C. So this manipulate open bracket, I'm going to manipulate this thing, comma, manipulate what? Manipulate this inside this thing. This thing is the one I start with, right? Graphic 3D, yellow cuboid, and this one can be blue, can be anything, cuboid. So this C here can be red, blue, or green. This thing, red, blue, or green. So when I do this, it's red. I click blue, it's blue. I click green, it's green. So now I can change color. I can change D, which is this distance. I can change G, which is that distance. Okay. So you can change whatever you like. Okay. Starting from this example. Again, and that's your homework. That's your in-class homework. So start with this. Start with this, right? Start with this. Okay. And then play around with it. Now, this is not the design part because the design part is given. I'm going to make two boxes, right? So in the future, obviously, you're not going to stick to the two box, right? You're going to have something else. Okay. For example, you can make ellipsoid. Now, ellipsoid, you have to see how many parameters it takes. That's a little bit too big, so on. Okay, so these are all the parameters. See? So I can do all kind of stuff, right? So instead of having box and box, I can have, so all kind of primitives you can start with. I don't care. That's not the point. Okay. I'm not asking you to do design again. Design is not part of it, but interactivity is. So let's say this is my design and I want to control how high this thing is. I can just say edge and manipulate here. And comma. Okay, H. Okay. Right? So this is what I mean by interactive. Now, okay, I'm going to give okay. Let me show you the step. Okay, guys. Now you don't need to do, I'm going to give you time to do this at the end of the class, so don't worry. Okay. I want you to watch my step. Okay, watch my step. This is actually how I did the design process. Okay. First of all, okay. First of all, instead of before I even manipulate, okay, before I even use manipulate, what I did was I create the design that I like. So this is what I mean. Okay, this is the design that I like. Okay, now don't have to worry about this, but notice it's got graphic 3Ds. It's got cuboid, that's a square bit. It's got ellipsoid, that's a circular bit, right? It's got cylinder and cone. So these are basically the graphic primitive, okay? If you talk to your friend in design, it's called graphic primitive. So you can draw anything from square, cube, cylinder, rectangle, and so forth. So these are graphic primitive, okay? I just have more of them because I want to spell out this. Now, the parameter, instead of manipulate, I just kind of like encode it as a function. So this becomes a function. This is a step I did before manipulate. Instead of manipulating the inside, I encode this as a function. So I can draw with the color of the letter, the minimum, maximum, X position. So these are called all my design parameters. Okay. It happens, you don't have to look at the detail, just look at the concept. So just now I show you what R, H, and color. Okay, 3 things. Now in this case, let's say I have 15 parameters. I make it a function so that whenever I specify individual parameter, I draw it. Okay. So this becomes one design. Okay. So if I call this function, let's go to a new page so it looks clean. Okay. This function draws the primitive with those choice. So before making a choice possible, I just say this is a parameter. Okay. So that's that. Okay. So some of these parameter control, for example, the size. So if I make it 100, it's a small thing. Okay. If I make something like large, okay. So first of all, I make the design into a function with parameter. Okay. The way I would do it, and I suggest you do the same, is design it with the parameter you like. Now, I happen to like this parameter. I don't know if my client likes it. I happen to like this parameter, but I'm gonna put, this is my preferred set. This is my preferred set. The client will do his own interpretation, what color looks best, what height, and so forth. I would save that. That's the one I would send to the 3D printer. Okay, but I would start with something I like. Okay, now from perspective of human cognitive factor, this thing I think correspond to my idea of what makes it a good design, because it's got visual language, it's got color differentiation, so yellow and blue are very clear. Okay, let's say so that's my thing. So once I did it, ultimately, and I'll show you. Ultimately, let's say your client my client, your client, can end up with this. So actually, his picture is different from yours. This is what I propose. At the end of the day, he likes this thing. Okay, this is hypothetical. Okay, this is hypothetical. Notice that it's the same function, but it uses different parameter. Instead of yellow, uses red. Instead of blue, uses green. Instead of this dimension, okay, so all this is a journey from here to there. So the step that I did was to make this manipulate, and this is where the manipulate comes in. Okay, the manipulate allows me to play with this. So my client can play with it. Okay. Now, ultimately, you end up with one thing. Okay, one thing. Now, why is this a modern concept? And this is where I literally want to show you this YouTube. And we watch a little bit of YouTube here. Actually, I asked you to watch it before class. How many of you honestly have seen it? The video that I think I sent. Okay, fine. Okay. So interactive parametric design. This guy, watch this. This guy. Let's watch YouTube together. Now, okay. So I'm going to move quickly because you don't have to watch the whole thing. But let's say about here should be good. Now, my idea is kind of independent, but this guy has very similar idea, except he does it for the local design for this. See, what he did, if you listen to explanation, what he did was he has only just the concept. The concept, this is a museum of mathematics. So the concept was the logo should be mathematical symbol. And one of the things about mathematics is the concept of symmetry. So he proposes that the design concept is use mathematical symbol in some color and make it into a hexagon to reflect the symmetry, or maybe not hexagon, maybe a octagon, right? So all this thing here is he did. I did look at the code. Okay, he doesn't show the code, but I assume it's kind of similar to what I did, which is to program the number of the symmetry. For example, the top left is 4. So maybe there's a parameter there that say 4. So use the pi 4 times. The bottom here, maybe use the number pi 8 times, right? And rotate it 8 times. So this thing here is very interesting. I think he started with no color. Okay, so look at this. See, this slider is exactly what I did, right? Exact same thing, same style, except here he chooses a letter. So maybe my guess is he has A, B, C, D, E, F, G, and this is the second letter, so that's a B. Uppercase, lowercase, symmetry, rotation, offset. So that controls how many copies of B's, how many angle, what's the angle, and he does this, and then he allows the museum owner or whatever museum director to play with it. Let me see. It should move pretty soon. Anyway, please go watch it. So somewhere in the middle, it's very good. Yeah. So he does this. See, all kinds of idea that's generative. See? It's the same thing as what I did, I think, right? Except he does this for the logo with letters. I did it with dimension. Now, this guy is pretty cool. He had some idea that I didn't think of, which is to say that the museum doesn't have to have a logo. It should have an application. And whenever you visit the museum, you can choose your own logo. It's like saying that I don't have a Basai logo. I just have BASCII. And then if you are a student, you like tall Basai, fine. You like short Basai, you can do whatever you like. So he's pretty advanced. Okay. But that's a concept. And he installed that as a part of an exhibit. So this is what I mean by interactive parametric design. Okay, it's interactive because user or you yourself can play with it. Parametric because the control is done by choice. Okay, whether it's color, length, height, ratio, angle, whatever. Okay, and this can only be done with tools, interactive tools. So that's why I'm teaching you like, Mathematica interactive. You can see how easy it is, right? It has a geometric primitives. It has a display function. It has a okay. Right. So again, you can be as creative as you like. I'll give you to the end of the class. I'll actually give you more time. Dimutu, where are you? Okay, I'm going to instruct Dimutu to leave my course view open till, let's say 4:15 or 4:30. Is 4:15 good enough, guys? Guys, up to you. Okay, 4:15 good enough, right? Okay, so they can turn in their thing by 4:15. Again, don't save it in fancy name. Save it as your student ID.nb. Submit it on the My Course View. Okay. Good. I think that's I'll show you later the further process. For example, once I've got it, I can deploy it in cloud. This is what I deploy in cloud. So somebody can actually go to this link and play with it. Okay. I can actually animate the animation. I just create a picture in series and so become a GIF. So I can create a GIF. And I think I show you, right, the GIF. So that's right. So what it does is basically just create a snapshot of different configuration and then save it and specify like some waiting time because GIF has a time dimension. So I just make it like 1/10 of a second between frame or something. Okay. So it goes from 3D to 2D to 3D, but in different shapes now. Again, my thing is, it's a journey between two design, one presumably my design, one presumably being the client's final design, right? So now this is something that you can do in all your project, right? Because your project can be visualizing a screen, an app, or anything, and that app has a design element that you don't have to specify yourself. Because what I realize is that if you do all the design yourself and you go to a client, and I find this as well, the client say, oh, I like this very much, but I want to make this font bigger, or I prefer that color. Instead of you going back to your shop and coming back in 2 weeks, you can just immediately change the parameter, and that's a lot more impressive. Okay, your client's more likely to take on your service because you're more responsive. So it's not like, oh, show me this design, come back in 2 weeks. No. They can actually play with this with you. And that's something that I want to equip you guys with. It doesn't matter if you go into the, which track. You don't, again, this is not applied digital intelligence. This is just design, right? So you don't, and there's no machine learning. There's no algorithm in this. This is just showing. Okay, so you have until 16, 15 to submit your notebook to Dimitu's my course view, right? Okay, ครับ I'll just hang around. ว่าไงลูก Okay. I'm pretty much done for the message, but you can ask me. Yeah, you can manipulate เอง you can manipulate color.
สามารถส่งไปอย่างนี้ได้เลยถูกไหมคะ
you ก็ส่งทั้งไฟล์สิลูก
ก็ส่งทั้งไฟล์ได้เลย
เนี่ย you save as .nb นี่
ต้อง .nb ใช่ไหม
มัน nb คือโน้ตบุ๊ก
อ๋อ nb โอเคแล้วอะไรต่อ
ใส่ชื่อหนูไม่ใช่ชื่อหนู id
สมมติหนูจะส่งอย่างนี้ก็ส่งได้เลย
ใช่หนูก็
หนู
เนี่ย
ไม่จำเป็นต้องทำดีไซน์อะไรอย่างนี้
ไม่ต้อง manipulate ตรงนี้ manipulate ตรงนี้ โอเค เช่น
manipulate
เนี่ยก็คือตอนเนี้ยหนูก็ทำสีว่าแทนที่เป็น red green blue manipulate distance อื่นบ้างสิอันนี้มันของผมนี่อย่า copy สิ
ใช่ให้ดู
ใช่
ส่งอะไรก็ได้
อาจจะเพิ่มตรงนี้ก็ใส่ brown ไปใส่อะไรใส่ brown เป็นสีเปิดอะไรเงี้ย
อ๋อแล้วอันนี้มีคะแนนไหมคะอาจารย์
นี่สิคะ
มีคะแนนแล้วมันวัดจากอะไร
ก็วัดว่าถ้าถ้าหนูส่งเหมือนที่ผมทำให้ดูตัวอย่างเป๊ะหนูได้0แต่ถ้าหนูปรับตัวนั้นปรับตัวนี้ปรับตัวนี้ Okay, yeah, you guys want to know what is the grading criteria, right? Well, the picture I show you, okay? If you go to the help page, you got the copy of that 2 block, right? Yellow and blue, okay? So what I did was to say, instead of making yellow and blue, I can change the color. I can change the position relatively. I can change the height. I can change the shape. The more you change, the more option you give, the better. Think about it. If you give your clients more options, more flexibility, right? Your clients will pay you more. Same here. I pay you in grades. If you show the same picture and just change the color, okay, you get 1 point. But if you can change the color, you can change the height, you can change the shape, you can change your orientation, and all this you can look up, right? Just by using F1. Okay, so the more changeable features you have, the better grade. Okay. ไม่งั้นหนูมันก็เหมือนอันนี้เลย copy เลยไม่ได้the more เหมือนลีลามากเยอะโอ้โหทึ่งเลยเดี๋ยวผมจ้างครับผมเลยแสดงว่า G เนี่ยมันอยู่ใน control ใช่ไหมแต่ U ไม่ได้ใส่ไว้ในนี้แน่เลยเนี่ยที่มีตัวเลยไม่งั้นมันก็ไม่ reflect มันเปลี่ยนที่จริงเวลาเปลี่ยนมันเปลี่ยนนะแต่มันไม่โชว์ไงเพราะมันไม่ได้ใช้นี่ไงผมใส่ใช่ไหม C นี่ยังไม่ใส่ถ้ายังไม่ใส่มันก็ไม่เปลี่ยนถูกไหม Yeah, there's a difference between entering the choice and using it. If you enter the choice to change the color, but you don't reflect that variable in the function, it's not going to change, right? So it has to reflect. ช่วยกันได้ลูกทำเป็นกลุ่มยังได้เลยไม่ว่าอันนี้ไม่ได้นะแต่ว่าเสร็จแล้วต้องทำให้มันได้ very good very good you can randomize color okay fine how do you randomize color okay this is where you do Google Mathematica okay let's say I don't know how to do this I just type in Google Mathematica how to random color there เห็นไหมครับ so in other words if I knew what the name of the function is I type in random color I press F1 it goes to the help page if I didn't know I just make a guess and go to Google just type in Mathematica how to change color randomly okay it goes to this page and there it is random color okay random 1 color random 3 colors all kind of stuff so I do Google so function that if I use this function all the time I don't even need to go to the help page because I know how to use it but if I know the name of the function I don't know how to use it I press F1 if I don't know what the name of the function is I just Google search okay Mathematica had to, so Mathematica, how to draw a cone. See? So you don't have to stick to cuboid. You can use cone. You can use a cylinder. You can have more than 2. You can have 3. You can have all kind of stuff. This is where your imagination comes. Okay, guys, one of your friends got something very clever. Instead of changing the parameter, right? She used the variable to represent the shape. Very clever, very clever. So instead of saying, you know, I click blue, click yellow, click green, I click cylinder, square, cuboid. That's very clever. However, the reason it didn't work is because cuboid, cylinder, they don't use the same number of parameters, right? Think about it. If I'm going to draw a cuboid, I need, say, point, But if I'm drawing a cylinder, I need a radius. So if it happens to be similar kind of things where it also takes 3 parameters, it might work. Okay. So in that case, what I might try is just use a default if there's a default. But it's very clever. I'll show you later. Okay. This is a very clever use of manipulate. Instead of choosing the parameter, chooses the function. Okay. But if you choose the function, again, the parameter change. You see what I mean? So if you have F has X, Y, it changes. But the second F may not use the same X, Y. Okay. So it's trickier, but yeah, it comes with the power of F has well. I do all the time as well, taking the function, but I make it when it's the same. to make sure you don't have to check her. I said yes. She said, change a whole bunch of things. And then change just one thing. Yeah. Then she had nothing to go. So it doesn't allow like afternoon time?
Yeah, kind of like that.
Okay, ขอบคุณครับ Okay, thank you, Jack. So yeah, I'll talk to you later. So don't worry about it. Just it's always less than perfect, but all right. How are you enjoying? Are you learning something too? Or good, good. Yeah, it's very powerful. So powerful. By the way, just call me Ajahn. Professor, I'm not a professor. A professor is someone who's got, the title. I'm just call me Ajahn. Yeah, we play with this a lot. I play with the 3D scanning with Dimutu. It's good fun. But what department are you? Do you go?
Political science.
Oh,
Technology.
okay. Well, that's very good. Very good. My wife actually works for the oil and gas, PTT exploration. So very good. You do the master too? Or?
Yeah, masters. Yeah.
Okay, good. Okay. Maybe we can have a good project. You might hanging around.
เ